So we are going to create our videos in two different bit rates, and bit rates kind of define the resolution or the quality of the videos. Okay, so we are going to create two different qualities of our videos for each video in our system. And the way the HLS streaming works is that it can detect the bandwidth of the user who is playing that video at a given time, and it will know whether it should serve a lower resolution video or a higher resolution video to that user. So in areas where internet is not really good, the network is bad, it should be able to serve the users with a lower resolution video. And so we are going to create those two different resolutions or two different quality videos so that it can actually serve them to the users. So let's start with what I call the medium bit rate of the video. So the higher the bit rate, the higher the quality of the video, and it will also require higher bandwidth to stream that video. So I'm going to start with a lower quality bit rate here, and that is defined by calling new x264, which is the encoding for the video, and we'll make it with the audio of AAC, and we can say set kilo bit rate, and we set that to 500 bit rate. Okay, and let's pull in the class or the namespace for the x264 conversion here. Then let's also pull in a high bit rate. That's for those who have higher bandwidth on their connections, and we're going to do new x264 conversion with audio quality of AAC as well, and set kilo bit rate. We'll set that to 2 times the lower resolution video. Okay, and here I should set that to bit rate. So we are setting two resolutions, one with 500 and one with 1000, and we expect that those with lower bandwidth will probably serve the 500 bit rate. All right, let's also generate a stream name. So in our database for the video, we need to provide a stream name for the video, right? So here I'm just going to say stream name, and the stream name is just a concatenation of whatever name we want to give to the converted file. So the HLS file, whatever name we give it will be the stream name, and then plus the extension, which is the extension that we are grabbing from our configuration here. So the stream name will simply be a unique ID. So we are going to generate a random unique name and concatenate that with the extension. And remember that the extension is in the format .m3u8. So whatever the unique string is that we generate here, we will add the extension to it to get a complete stream name. And that is the file name that we will save the video as in DigitalOcean Spaces. Then after that, we can now actually upload or kick off the conversion process for the video. So let's call the video, which we already opened. So we have the video open as an FFmpeg object here. So we can call a bunch of different methods on this video. Okay. So the first thing we want to do is to say export for HLS. So export for HTTP live streaming. And then we want to say with rotating keys or rotating encryption keys. And with rotating encryption key means that every part of the file that is created should have a unique encryption key to it. Okay, so that before you pull out that file, before you're able to play that video, we have to send a request to obtain the encryption key for that video, and then send a second request to actually get the video and render it to the user in the front end. So for each part of the video that we save, we want it to have a unique encryption key. So that's why we are calling it the rotating encryption key. If you look at the package, there are options where you can use the same encryption key for all your videos, but I want to go with the more complex scenario of having rotating encryption keys because it also offers a better security for your videos. So here it takes a closure which receives the file name and the contents of the video. So it receives the file that we want to encrypt, which in this case will be each of the HLS parts and the content. And in here, we have to specify where we want to save those encryption keys. Because we are working in DigitalOcean spaces, we are going to create a subfolder in our DigitalOcean bucket called secrets. Okay, and in the secrets folder, we are going to store our keys. So I'm just going to create a folder here called secrets, and that is in the DigitalOcean bucket, and that's where we are going to store our keys. So over here in Laravel, we're just going to call storage disk, and the disk we are looking for here is DigitalOcean, and we put the secret keys. So in a subfolder called secrets, the file name of the secrets, and the contents of the file of the video. Okay, so it will generate a secret key for each of them parts of the HLS files, and we'll save them in the secrets folder on DigitalOcean. Then after that, we can also call other methods on the video, like onProgress. Now, onProgress is what is going to allow us to notify users in the front end on the percentage of video that has been processed. Okay, so it takes the progress percentage, and we can use that information here to update the database, because remember that in our video record in the database, we do have a field for processing percent. So we can update the database here by just sticking the progress into that field. So each time we get an update from the process, we are going to update the database. So this video update, and we just need to put processing percent to whatever the progress is that we receive in this callback. At the same time, we will be later on broadcasting an event here that we will listen in the front end in real time. And so we'll be making use of WebSockets to broadcast the event in the back end, listen for it in the front end in real time, and notify the user for how much of the video has been processed. Okay, so we will get to that later on when we start looking at the events and WebSockets. So for now, we can actually just lock the processing percent. So I'm just going to say info progress, so that we can see the progress for the video in our log files. And now we created different formats. We created two formats here, the high resolution and the lower resolution. So we have to add them in here. So we call the add format function on the video. And the first one we want to add is the bit rate, or the mid bit rate. And that takes a function which receives the media file, and we can just scale the media to whatever size we want. So whatever size we want to scale the video, we can do that here. In this case, I want the video to have a 720 by 480 resolution. Okay, so that will be the size of the video on a medium bit rate for the smaller resolution. We can also do the same thing. In this case, I want to do it for the higher one. So the high bit rate, I believe is what it's called. And we're going to make the size much bigger. So it will be 2080 by 720. Okay, so that's a higher resolution, a video, a bigger video, and this one is going to be a smaller video. And then once all of that is done, we want to save it to disk, and we provide a disk where we want the video to be saved. In this case, we want the video to be in the stream disk that we saved in the video record. So this video stream disk, and we call save on that. And what do we save here? We save this video. We save the video under its ID. So the subfolder will be the video ID / the stream name that we created up here. So we did create the stream name, which is a random string plus the extension of the file. So stream name, and we close that in here. So things are looking okay, and we have an error here because I said process. We should be updating that with progress. And let's see, file name should actually be like this. All right, if we find any errors later on, we'll come back and fix it. But for now, it looks good. So once we have the video processed, okay, once we've done this and we are successful in the process, then I want to update the video record with the final information, because at the top, all we updated here was the duration in minutes for the lecture, but we also have a duration in seconds for the video. So I want to update that information here. I want to update it with the stream name, the status, as successful or failed if it did not fail, and all of that information. So let's update the video. So this video update, and duration, let's see what that field is called. Duration seconds. Okay, so duration seconds is going to be the duration that we got from up here. The stream name is going to be, of course, the stream name that we created. The status up to this point, it means it's successful. So the status will be video status successful. The processing ended at time will be now. So whatever the current timestamp is. And the failure details, if it makes it to this point, then it did not fail. So the failure details will be null. Okay, so we want to clear anything that might have been recorded in that field as a failure detail. And when we are done, again, I'll send another broadcast of the event here just to tell users in the front end that everything was successful. And once that is also finished, FFmpeg, that's the Laravel version, it gives us a functionality to clean all temporary files that were created by this process. Because you can imagine when it takes the MP4 version of your video, it's creating lots of temporary files to convert that into whatever format you want to stream it in. So this package gives us a function called cleanup temporary files, and that basically cleans up all the temporary files in our file system. Now, I also want to delete the files from the temporary disk that we created here if the process was successful. So if we are done and we've uploaded the files to DigitalOcean, then I want to empty the temporary disk. Again, it's different from cleanup of temporary files. The temporary files are in our file system on your machine. The disk is the Laravel disk that we're using to save the video before we can process it here. So I also want to delete that temporary file if we are done with processing. So if the storage disk video temp disk exists, this video temp path. At this point, I always like to be extra cautious by just checking to be sure that the file exists before I delete it. And if it does exist, then we want to open that file. So this storage disk, the temporary disk, and we want to call the delete method on that file. So it will physically delete the file from our temporary directory in Laravel. And if those two things are done, then we are good with processing the video at that point. Now, because we are working with a job, I want to also handle the situation where we have a failed job here. So this code will run if the job fails. So if we run this job and it's marked as a failed job, what I want to do is to update the video record in the database to indicate that it failed and provide the failure details in the database. And to do this in Laravel, we can add a function in our job class called failed. And that field takes a throwable object, and that's an exception, and we'll instantiate it to null. And so if the job fails, what I want to do is do an update of the video. So this video update, and we'll set the status to fail. So video status failed. We'll set the processing ended at, again, it's ended at now, and we'll set the failure details to the message that we receive from the exception, okay, from this exception. So we'll just call exception get message. And we'll also do this video lecture update duration in minutes. We'll set it back to 0 because at this point, again, the lecture doesn't have any video. So we'll reset the duration for that video, for that lecture to 0. All right, it looks like things are looking good here. And we'll come back in the next lesson and quickly test this functionality to be sure that it's all working. So see you in the next lesson.